Okay, thank you all for coming, and thank you especially to Professor Turchin for coming to speak to us. I'd like you all to turn off your mics except for Professor Turchin. And after his talk, if you want to ask a question or make a comment, please use the hand signal, and I will call on each of you in order as I can do. Now, I'd just like to briefly introduce Professor Turchin to you. He has
Before we
at
do,
least
Marion,
10...
can we, Mark and everybody else except Marion and the speaker, can you switch off your cameras and microphones?
And microphones. So Professor Turchin has, I think, about 10 books at least still in print, as well as many articles. And I understand today's topic will be in a book forthcoming, if I understand as well. The topic is the Great Holoscene Transformation, Cultural Macroevolution of Social Scale and Complexity. Professor Turchin is well known for treating macro history, sociology, politics, economics, whatever, on a large scale over a long period of time and doing it quantitatively. So this is going to be very interesting. So I think I'm going to apologize too to Professor Turchin and others that Jeffrey Hodgkin, our president, can't be with us today. He was very disappointed, but a medical appointment came up at the last minute that he could not refuse. So he'll be sure to watch the video. And so for that, if you're all turned off except Professor Turchin, I'll ask him to go ahead. Thank you, Professor Turchin, and go ahead, please. And I'll turn off my mic and camera as well for now. And I'll come back on after you finish talking to take questions and comments.
Thank you for this introduction. So today, the topic that I would like to talk about is the Great Holoscene Transformation. What complexity science tells us about the evolution of complex societies. Let me start with this overview of social evolution of humans. For most of the evolutionary history of our species, we lived in small-scale societies of foraging bands, maybe counting in tens, hundreds, at most low thousands. And then during the Holocene, roughly speaking, the past 10,000 years, the social scale and complexity of human societies has dramatically increased. So here I am representing the social scale by looking at the typical population size of polities, politically independent organizations ranging from farming villages in scale through chiefdoms, different kinds of states, to large nation states. And this transformation has been literally astronomical, 5 or 6 orders of magnitude. That's, I think, is a very impressive fact of social evolution in our species. At the same time, there was an institutional transformation, which is qualitatively captured here by looking at how the relatively egalitarian societies evolved into centralized societies and later on in societies organized as states. So the big question here is, what are the evolutionary mechanisms that explain this dramatic transformation? And there are many theories. Pretty much most everybody agrees that agriculture is a necessary condition for the evolution of complex societies. But after that, opinions diverge. Some theorists focus on the functions that our societies can fulfill. Other theorists focus on conflict aspects, including both internal conflicts, such as class struggle, and external conflicts, such as warfare. Many other theories invoke additional mechanisms, such as religion. What I will be focusing a lot is on one particular theory stemming from the relatively new discipline of cultural evolution. It's called cultural multilevel selection. So this list is not meant to be exhaustive. There are literally hundreds of theories, and theorists over the past at least 2,000 years have been proposing various types of explanations. So in my talk, I would like to address two main themes. First of all, I'll talk about how we can think about all those different kinds of theories, and I would propose that the conceptual framework of cultural evolution, and specifically cultural macroevolution, is the one which allows us to bring such a great variety of theories to, so to speak, a common denominator. Right. The second theme is, of course, theories without data are sterile. So I will be talking about how the analytical framework of nonlinear dynamics. So this is how complexity science actually enters into this equation. How this framework allows us to test evolutionary theories, and the critical characteristic of data that allows us to approach mechanisms much more closely, I would argue, is the time component. All right, so let's talk first of all, what is cultural macroevolution? All right, similarly to the distinction that biological evolutionists make, we can distinguish between microevolution and macroevolution. So cultural microevolution has been actually treated exhaustively over the past 30 or so years, and it is frequently defined as the change in the frequency of cultural variants within a population. So, for example, Calvalli-Sforza and Feldman about 40 years ago have proposed that explanation. And by the way, what is culture? In cultural evolution, culture is defined specifically as socially transmitted information. All right. So it could take many varieties. It could be music tunes. It could be ideas about how the world works, and all the way up to traits of whole societies. All right, so if cultural microevolution focuses on the frequency of cultural variance, then cultural macroevolution focuses on large-scale changes in cultural traits of whole groups. All right, so the types of cultural traits that we are interested in are things like institutions, for example. So in biological evolution, the dogma is, at least, and the majority of biologists agree, is that that macroevolution, biological macroevolution, can be reduced to microevolution. All right, although it doesn't necessarily mean that we have to study it that way. But in cultural macroevolution, some group level traits are actually emergent properties of groups and not reducible to individuals. So for example, if you think about institutions such as governance institutions, for example, autocracy versus democracy, it is impossible to say that I have an institution. Institution is a trait of collectives. So I may hold different types of, I may hold some social norms. For example, I may be more an authoritarian type, or maybe more egalitarian type, but it is impossible to say that individuals have institutions. And that means, as David Sloan Wilson has argued, that when we think about characteristics of human collectives, the way to think about the evolution of them is to focus on human collectives as the units of selection. All right, so now let me. I'm not going to show many equations, but I would like to stress that in order for us to do a proper job of testing theories, we really don't want to test verbally formulated theories against each other. We want to use some kind of a formalized framework, which is generally, referred to as mathematics. And now the type of models that we use to translate verbal theories into mathematical models can vary. So here, for example, I'm using a system of difference equations. Other possible approaches could use continuous time differential equations, or in many situations, when we want to focus on modeling complex interactions, we have to use agent-based models. The particular mathematical framework is not as important as the necessity of using formalized models, so that we know that model predictions necessarily follow from premises, which is not the case when you formulate theories verbally. So today I will be using this particular mathematical approach from complexity theory, or specifically from nonlinear dynamics approaches, to use as the general mathematical framework within which different theories can be expressed and compared to each other. So specifically, X, Y, and Z are state variables, which tell us about the state of the system, right? This could be things that we would like to investigate. For example, X could be the social scale, polity size, all right, and Y could be some other characteristics, for example, institutional complexity, or governance, or sophistication of governance, and so on and so forth. So in this system also, there are some variables which are exogenous. So the state variables are endogenous. They represent dynamical feedbacks between different aspects of the theory. But there are also exogenous factors. Many people think about maybe climate as such, but also essentially any kind of change that is not modeled as part of feedback loops could be modeled as an exogenous factor. And this could be, as we will see, this could be things like, for example, changes in technology that are not modeled explicitly in the framework, and many other types of things. All right, so this X, Y, and Z, and so on, they are characteristics of polities. I prefer not to talk about societies, because many different authors mean very different things when talking about societies. So a polity is a much more concrete unit of selection compared to other types of human groups. It's defined as an independent political unit, and it can scale. It can vary in scale from maybe a single village of farmers that is self-governing through a variety of centralized societies, states, and empires. All right. So this nonlinear dynamical framework, I argue, is very useful because it really captures the essence of evolutionary processes, which is often famously is characterized as descent with modification. So both the past the past history is important, and or heredity, if you will, and change. So this dynamical framework that captures both of this, both the continuity and change. Secondly, this is a very flexible, it's a very general and flexible mathematical framework, because this system of equations can represent a variety of dynamical processes, starting from random walk, which is biased or unbiased. In fact, it has been used in biological evolution biological macroevolution to model processes such as speciation and things like that. All right, and it also can be capable of producing even more esoteric dynamics, such as cycles, chaos, and many other things, multiple basins of attraction, and so on and so forth. I won't be focusing on those more exotic dynamics later on, but my interest is to look at such evolutionary types of behavior as neutral drift, directional selection, stabilizing selection, and as such. All right, so enough of this mathematical things. Now, so how do we use this framework to test different types of theories? So here is a proposal. Essentially, the many dozens or even hundreds of theories proposed by various authors, from ancient Greeks through medieval thinkers and sociologists, social scientists of today, I propose we can characterize them by looking at two dimensions. First of all, we ask what theories are attempting to predict, because different theories focus on different aspects of the great Holoscene transformation. So some theories are interested in explaining why the states evolved. Other theories talk about centralization. Yet another variety of theories focuses on social complexity, however defined. And yet other theories look at the social scale. So that's one dimension along which we can sort different theories out. And secondly, what are the main explanatory processes? And so this means essentially what are, so the first question, response variables, what is the X that we are focusing on the left-hand side of the equation? And then we are asking what are the Y, Z, and so on that are proposed as main explanatory processes: population pressure, circumscription, various kinds of functional theories, conflict warfare, and so on and so forth. This is just a sample of theories, obviously, illustrating how we can sort them out by this in these two dimensions. So what this means is that if we want to test theories, we need time-resolved data, both on response variables, what theories are trying to predict, all right, and on and variables capturing or proxying main explanatory processes. And once we have this type of data, we can, in fact, start testing theories against each other. So let me just briefly say that one of the main theories that I would like to test against other alternatives is cultural multi-level selection. So the old name of this theory is group selection, and this is, of course, a highly controversial topic in evolution in general. Notice that I prefer to call it multi-level selection because the essence of the theory is that a particular trait can be under divergent directions of selection acting on different levels. So famously, evolution of cooperation is a balance of selective forces acting on individuals versus selective forces acting on groups. All right. All right. Now, relating this general theory to the more specific theories about the evolution of large-scale complex societies, what is interesting and nice is that CMLS integrates functional and conflict theories, but not in a boring way, such as, oh, everything matters. No, but in a very specific way. So what's important is competition between polities, between, well, societies, if you will, or more specifically between polities, all right, which often takes, or especially in the last 10,000 years, has taken the form of warfare. But such competition between polities is what drives functional integration within polities, increases their capacity for cooperation in a variety of ways. So, so this theory actually integrates both functional and conflict explanations. All right, so during the Holoscene, the primary mode of competition between polities was warfare, and that is why we will need to come up with different variables or proxies to capture the intensity of interpolity competition. All right, so that's one thing. The second thing is that I will argue also comes from cultural evolution. This is known as cumulative cultural evolution. So technological evolution specifically is one of the best examples of cumulative cultural evolution. And as I will argue later, it can drive the intensity of warfare, specifically the evolution of military technologies. So, so the new discipline, relatively new discipline of cultural evolution, I argue, gives us two very general theories, CMLS and cultural and cumulative cultural evolution, and that, of course, many thinkers of the past and social scientists today have used such mechanisms without necessarily calling them this way. All right, so talking specifically about interpolity competition, there is a set of theorists that have focused specifically on the early modern period and focusing on the rise of Europe, right? And they have explicitly invoked interpolity competition in the form of warfare as the driving selection force that resulted in transformation of Europe over the past, let's say, 500 years or so. So these are the theorists who have focused on the military revolution of the 16th century that is typically associated with the use of gunpowder weapons, such as cannon and firearms. But also a very important aspect of it was dramatic improvements in ocean going ships that allowed the local European phenomenon to become global during the past 500 years. And these theorists, speaking specifically about Europe in the last 500 years, have argued that without calling this cultural multi-level selection, they have explicitly argued that it was the intensification of warfare that imposed interstate selection and resulted in cultural macroevolution, which involved many different things, such as other types of defensive features, such as fortification, organization of warfare, the scale of armies, and that if you want to have a large army, you need a large state, and institutional evolution that evolved to support the state cohesion and its capacity to compete in the international arena. And in fact, the language that many of these theorists have used evokes evolutionary theory in a variety of ways. Right. So one thing is that the military revolution of the 16th century was not the only one, and was not the first one, and probably not the last one either. So the Iron Cavalry revolution of the first millennium, BCE, in particular, was, I would argue, equally transformative as the gunpowder and sailing ships revolution of the 16th century. So this combination of iron weapons and armor, together with ability to horse ride and use control horses and use it as a mobile platform for projectile, such as, of course, bows and arrows, that has really revolutionized warfare. And as we shall see later, there is a lot of evidence suggesting that it has had dramatic consequences for social evolution. And there were other military revolutions, such as bronze weapons and armor, chariots, and so on and so forth. So what these observations suggest is that evolution of military technologies, which is an example of cumulative cultural evolution, right, have impacted the intensity of interpolity competition, and therefore have been a very important long-term factor that affected evolution of human societies. So why do I talk about Iron Cavalry revolution? I talk about it because cavalry was invented in the Pontic-Caspian steppe, and then spread very rapidly east-west and then south. Whereas iron was invented independently, apparently, certainly in the Caucasus and also in North India. It appears to be an independent centers of metallurgy. But the problem for statistical analysis is that it happened roughly at the same time, and oftentimes these two technologies spread together. So it is often difficult to separate the influences of those two technologies, and therefore, for pragmatic reasons, I prefer to treat them as part of a single package, at least in the story that I will be presenting. Okay, so so the next step. So now I've presented you with the theoretical and mathematical framework, which guides us in data collection. So let's talk about data. All right. First of all, in order to connect the mathematical framework to data, essentially what we do, we invert in time the previous model, whereas the dynamical systems approach that I presented a few slides ago looks at how the past influences the future, right? So we use the knowledge of the past to predict what happens at the next time step. Now we are inverting the time arrow, and in order to test theories, you want to ask how the present state of the system, such as y in a location I and at time t, is affected, first of all, by itself at various time lags. Secondly, we need to take into account spatial influences, then possibly the autocorrelations resulted to shared phylogenies, so which are represented here. And finally, the most interesting part is the various types of drivers, the independent variables that have been proposed by different theories as explanatory factors. So the idea is to use this dynamic regression. Is dynamic because we are using the past in an attempt to predict the present, right? So there is an explicit time component here. So to use this dynamic regression to find which of the proposed factors proposed by various theories have the best explanatory power. And then by implication, this is how we test theories, right? We ask how data, how factors proposed by different theories, what is their explanatory power, and the stronger the explanatory power, the more the degree of support in a theory. So the statistical exercise is essentially model selection, right? We want to find out which of these terms, including the various autocorrelation terms and the drivers, what is the best combination of these terms that gives us the predictive ability. And that is a kind of an answer that we are seeking in this analysis. All right, so this formalism allows us to investigate a variety of causal scenarios, such as direct, unilinear causality, where X affects Y, but not vice versa. And notice that I'm using time subscripts to break the curse of simultaneity. When we have X and Y, when we have a static data set, such as many ethnographic databases that tell us what are the correlational patterns between X and Y, when you find strong correlation between X and Y, it is really impossible to detect which direction the causality flows. But when you have time-dependent data, then because the basic idea is that causes precede effects, we can distinguish between the possibilities such as that the causal error points from X to Y or from Y to X. All right. In addition, we can look at possibilities of mutual causation. All right. And finally, the possibility of so-called, well, one might say spurious causation, when X and Y are correlated, not because they directly affect each other, but because there is some third factor or factors such as Z that drives both X and Y, and that's how correlation arises. I want to emphasize that this time-resolved data and this approach is not panacea, because determining causality is a very complex and approach, and so simply just by observing that X changes in X precede Y is not enough often to prove causality. What this framework allows us, it allows us to test causal theories, because different causal theories make predictions about different time relations between variables. But so we can, using this approach, we can say if whether theory A is better supported than theory B, all right? But it doesn't mean that theory A is the true one in the final sort of sense. This is more sort of Popperian approach. We are testing theories against each other, and we can, as a result of it, some theories, the degree of belief in some theories goes down, the degree of belief in other theories goes up, but we never have the final answer of what's driving, because there could be another theory, C, which actually even predicts data even better, and so we'll have a greater degree of support than currently best supported theory. All right, and the other thing is that this approach requires time resolved data. And that's why back in 2011, together with a bunch of colleagues, we have launched Seshat Global History Data Bank, whose goal was to collect such time-resolved data about past societies. All right, so we want to both survey a diversity of social evolutionary trajectories and also identify general patterns. And the main goal, the one that I will be focusing on today, is testing and rejecting, that's very important, theories of social cultural evolution. So whereas previously the theories, different types of theories explaining evolution have been accumulating, our goal is to actually start retiring some of those theories to the cemetery of dead theories. All right, so I won't go in great detail about the approach, just because we've been talking about this for many years and publishing over the past 5 years quite a number of articles. But initially our approach was, we had a global sample, but now we are filling in the data between those sample points. And the idea is that at each of the sample points, for example, Upper Egypt here, we drill back from the Industrial Revolution back into Neolithic Revolution. So our approach looks at this period between Neolithic Revolution and Industrial Revolution. We don't talk about foraging societies much or at all, right? And we are not going into the last 100, 200 years, right? We focus on the period in between. All right. So, and as I said, we have started filling in. So the data set that I will be talking in a minute, it focuses on not 30 original sample points, but 35, which and we have since then we have done a much better job filling in, especially Africa and South Asia and a few other world regions in between. All right, so just to give you an example. So for example, if you want to explain the evolution of the state, right? How do we approach this question? First of all, we don't try to code society. Is it a state level society or not state level society? Instead, we break the idea of statehood into a variety of dimensions. So first of all, is there internal specialization of governance? Specifically, are there full-time specialists in administrations, in warfare, in religion, other specialized government buildings? This is in particularly useful for archaeologically known societies. If there are administrative specialists, what are the characteristics of bureaucracy? What kind of legal systems have, and so on and so forth. So this is the typical approach we use to quantify many different aspects of past societies. We collect this data essentially as presence or absence, but also allowing for uncertainty in a variety of ways. And then here, for example, to come up with an index of specialized governance, we simply add together the binary variables, all right, and then we scale it to 0 to 1. So here are 11 variables, so we divide the sum by 11, so that 0 represents absence of all in all variables and 1 presence of all variables. All right. So when we do that and we look at our data, so here are the trajectories for 10 different world regions in the sample size. So that shows how specialized governance, see here on the scale of 0 to 1, how it has changed in different world regions over time, over the past 7,000 years or so. And what we see here, what I want to emphasize is, first of all, that there is no inexorable progression. There is a lot of ups and downs, all right? So that's one thing. Secondly, there is a huge variety in how early governance started to increase and where it did. So this is very nice feature. It means that this variability is key to testing theories in the statistical domain, because it gives us a much more informative data set than would be otherwise. And so, for example, if we look at correlations between government specialization and one particular measure of social scale here, log-transformed palliative population, you see that there is some interesting patterns. First of all, there is clearly some correlation. It's non-linear, all right? There also, you can see there are some concentrations of points. So all kinds of interesting patterns start to emerge. But we have much better data than static correlation of this kind. We have time resolved data, and that allows us to test theories. So I want, again, about 3 years ago, we published a big article in Science Advances. So I won't be talking a lot about details. What I will do is I just hit the highlights, especially because my time is rapidly running out. All right, so I'll show you a summary table with different types of theories. All right, and here are some conventions that I use to represent that. So what we have here is the table in which we have a dependent variable. We have the explanatory variable. We look at 3 different explanatory variables. One is scale. That's essentially the first principal component of log-transformed polity, population polity, territory, and population of the largest settlement. All right. We have another response variable is a measure of hierarchical levels in governance, in administration, in military and settlement hierarchies. And then governance is that variable that I explained a few slides back. So these are the 3 variables on the left-hand side of the equation. And on the right-hand side equation, we have a variety of proxies. So here are 17 proxies for 5 classes of theories of agriculture, various types of functional theories, social scale, internal conflict, religion, and external conflict. I won't go in great detail, but I'll return to some of these more important variables in a minute. And what we see here is that 2 types of variables turn out to be important. They are selected by the model selection process. First of all, it's 2 features of agriculture. One of them is the productivity of agriculture as measured in the tons of carbohydrate crop per hectare per year, all right, or the antiquity of agriculture, how many years have passed since agriculture became common in a particular region, right? Then warfare intensity, specifically the sophistication of military technology, and the military revolution, the spread of joint iron metallurgy and cavalry technology together. So, both two theories, the external conflict, interpolitical competition conflict, and agriculture, appear to be capable of predicting the next time step. In other theories, we can see here and there, sometimes they are selected in models, but not don't have a very strong statistical support, as indicated by this parenthesis. And this is what we would expect when we test many hundreds of theories, because remember, we test all different types of combinations of these variables. So there is, we would expect some time just by chance that particular predictors would be selected. All right, but they are don't have strong statistical support, unlike the other two factors. Now, agriculture is not particularly surprising, because, as I said, there is a general agreement amongst among social scientists that it was a necessary condition. But what is a surprise is that we don't see much or any support for functional internal conflict theories or religion. What we see is a lot of support for interpolitical conflict, which is, of course, what cultural multi-level selection predicts. All right, very quickly. Also, I want to emphasize that when we do model selection, we do it by using out-of-sample prediction, using the k-fold cross-validation specifically. Details are in the article. All right, so very quickly, just to give you a bird's eye overview, remember we talked one important feature of agriculture is productivity. So here are some examples of data that we have. On the left-hand side, we have yield in tons of crop per hectare per year. On the x-axis, we have time. And this curve represents the evolution of agricultural intensification in different parts of the world. All right. And so when we, for example, look at correlation patterns between, let's say, this agri, which is the intensity, productivity of agriculture, and let's say governance, we don't see a whole lot of correlation here, right? But it turns out that once you include this factor in the dynamical regression, it does increase substantially and statistically highly significantly the ability to predict what governance in combination with other factors. All right. Also, the time lags between the adoption of agriculture and appearance of one particular, measure of social scale, which is states controlling large territory. All right, we see that there is actually fairly strong bunching around 2,000 years. All right, but agriculture is a necessary factor, but not sufficient. So there is a bunch of other areas which had agriculture for a long time, but they had no macrostates until European colonizers came. All right, and by the way, the fact that this variable is selected as a predictor variable actually says that it's not really the time since adoption of agriculture. It's a proxy for something else. We don't know, something that we have not included. We don't have quantification of, something that accumulated. All right, and drove and increased the probability of moving up in social scale and complexity, right? So in a way, it represents a failure of our approach, because we still need to find out what is it that something that accumulated. All right. So So the next thing, let me briefly talk about specifically military technology. All right. And the way we do it is a similar way that I talked about governance. So we have 46 binary variables where we look at various aspects of military technologies, such as the use of different types of metals, what is the sophistication of projectile technologies, what are the hand weapons, armor, what animals are used in conflicts, and the sophistication of fortifications. And the MUTEC variable is essentially adding together all these binary variables, so on a scale from 0 to 46. And so when we look at the correlations between these variables, so here on this complicated graph, I have 3 dependent variables, 3 response variables, so scale, hierarchy, and governance, and simultaneous static correlations of those with MUTEC. You see that there is a stronger correlation with MUTEC than on the lower panel, the correlation between the same response variables and agriculture. All right, but once we include both types of variables into dynamic regression and do this k-fold cross-validation, we see much stronger predictability. All right, so this is the predictability between observed variable and the variable predicted by fitting the dynamic regression model. All right, so start wrapping up. The causal diagram, again, and keep it in mind that it's as always in science, is a tentative thing. Given the set of theories for which we were able to develop proxies, data proxies, the current interpretation of it is that social political complexity, as expressed in these 3 different aspects, is driven by 2 main sets of factors. First of all, factors representing interpolity competition, all right, MUTEC, and the joint spread of iron and cavalry. And secondly, by 2 aspects of agricultural productivity. I haven't talked much about it, but notice that there is a mutual evolution suggested by best fitting models. Specifically, governance has a strong statistical effect on agricultural productivity, which makes sense, all right, that more sophisticated in governance societies actually use some of that sophistication to increase agricultural productivity. In other aspects, we have mostly the flow of causality goes in one particular direction. All right, and so I'll go quickly through this slide. So we can do a variety of things. For example, we can look at the fitted relation from the specific looking at social scale, all right, and use that to compare some features of the data. So here, for example, we are focusing specifically on the effect of joint spread of iron and cavalry. In the data, we see that maximum scale, so here averaging 3 largest polities in our data set, we see that there was fairly rapid advance from a previous military revolution, then some stagnation here, another kick, and remember that this is a logarithmic scale, so we see a very substantial increase, and then again, some kind of a stabilized selection in this region. And this is what the fitted model predicts. So it shows a very similar pattern. We can look at association of the spread of these military technologies in space, and it is very clear one. And also what we notice is that if we look at, for example, within Afro-Eurasia, if we look at 4 different regions of it, right? So Central, which is basically Iran, South Asia, East Asia, and Europe, what we see especially a clear correlation between the appearance of cavalry and the rise of the first mega empire as a state controlling more than 3 million square kilometers. So we see here that in the central part of Afro-Eurasia, the time gap was about 400 years. In South Asia was 300 years, in East Asia 300 years, and in Europe it was 400 years. So there is a fairly typical time. It takes 3 to 4 centuries for the kick that the spread of this technology does in intensifying warfare to percolate into noticeable increase in social scale. So cultural evolution is a slow process. All right. So we see similar effects when different types of other military revolutions, such as bronze, chariots, here's iron cavalry, here's gunpowder. So here we are looking at another aspect of scale, which is the log transformed polity population. All right, and we see a very similar pattern of punctuated equilibrium, really. But it's really not punctuated equilibrium in the traditional biological evolution sense. It's a result of cumulative cultural evolution, which, however, is not smooth, but rather is characterized by episodic advances in different kinds of military technologies. And just like gunpowder has resulted in the fan of other advances, both in military technologies and in institutional evolution. Previous military revolutions have the same complex effect. All right, and it's okay. It's 10 o'clock, so I won't be talking much about other theories, and I won't be talking about much about some additional interesting dynamics that we see in our data. So let me just skip through this part. All right, and just finish with this overall sign. So what we see, this is a way to look at our data from Seshat in a similar way of it's like stellar evolution, right, in astrophysics. All right, so here we are, this graph represents 4 different dimensions of our data. First of all, we'll look at this comp is combination of different institutional things. So here we're talking about governance, information systems, sophistication, and other things, all expressed in one dimensional space. All right, and so it is scaled from 0 to 1. All right, so this is institutional complexity. This is the scale, social scale, which is, remember, it's a combination of population, territory, and population size of largest city. All right, all on log transformed scale. So here we are talking about societies. Typical size of societies 3 corresponds to thousands. Small scale polities in thousands or even hundreds of individuals. Here we're talking about hundreds of millions. All right, the third dimension is the size of this circle. So that reflects the productivity of agriculture. And finally, the colors represent military technologies scaled. These 44 different binary variables scaled from 0 to 1. So we see that we start with pretty low values of military technology and end up with pretty high military technology. So this is what really the main driver is intensity of interpolity competition as proxied by military technologies used in a particular region. So what we see here is that there is a cloud of points But what's most interesting is that there are forbidden regions. So this corner here, we don't really have low scale and high complexity, institutional complexity societies, simply because institutional complexity is costly, and therefore it is not needed for small scale societies. And vice versa, we don't see much here in the high scale and low complexity. And that's because institutional complexity is necessary to hold together large-scale societies. Large scale is costly, and it needs to be managed, and this is where institutions are important. So this is a result of selection processes that actually essentially forbid these societies to enter these regions. And of course, there is a nonlinear relationship here in which we can also talk about. So I think at this point, I will stop talking. Thank you very much for attention, and I'm very happy to address any questions that you might have.
Thank you very much, Professor Turchin, for a very interesting talk. And I would recommend the Science Advances article for those who are waiting for the book. I looked at it before our meeting, and it was very good, very interesting article. So I'd ask people to please use the hand function to ask questions or make comments. Just put up your hand and I'll call you by the initials probably because it's easier that way. Who would like to go first? JS, please go ahead. Open. You can turn on your picture and your voice.
Yes, thank you for a really interesting talk. Could I ask you to go back to the slide where you have the boxes and the arrows that are sort of trying to give a causal interpretation? And yeah, so what struck me, I think this is quite an interesting attempt at getting to the causality. But what struck me here is that on this picture, in the left top corner, it would seem that the military revolution, so I would sort of interpret that as military innovation, seems to be independent from what's going on elsewhere, in the sense that there's only arrows running away from it and nothing running towards it. Should we attribute any significance to that? It seems sort of counterintuitive to me that if this is about innovation, that it would not be in any way related to something like social political complexity, because I would expect innovation to be more obvious or more rampant in larger scale social entities.
Yeah, that's a very good question. So I didn't talk about it, but we have in a separate article, we use the same dynamic regression approach to look at what are particular drivers of a military revolution. Well, specifically because MilTech is a nice quantitative variable, right? Going from 0 to 44, and actually there are halftones there. So we use that as the response variable. And it was to our surprise, we did find that agricultural productivity had an effect, but none of those factors actually influence evolution of military technologies. And the same thing here, both iron and cavalry. So let's talk about iron metallurgy and cavalry. So remember that this war, in fact, let's see, let's get back to that map. Actually, let me go back forward. Here. So here, what we see is that both, it is really counterintuitive, but now in retrospect, we see that this makes sense. So both types of technology were invented actually in societies which were not particularly high on the complexity scale, specifically the nomadic societies living in the Pontic-Caspian steppe are the ones who invented horse riding, all right, that it rapidly spread through the Great Steppe and then impacted the agricultural populations living in the underbelly of the Great Steppe. So this was, in a way, an exogenous factor. So in the model, we treated it as an exogenous factor because the rise of this particular technology was not dependent on high social political complexity. And similarly, interestingly enough, metallurgy was also not, iron metallurgy was not invented by those complex societies. It was actually invented elsewhere, and then, of course, was eagerly taken up. So when we look at the dynamic regression of Miltech, what we find no effect on of social political complexity there. But what's important is, first of all, agricultural productivity does have some effect, but most importantly is the location. So the closer you are to that network, exchange network within, first of all, the world system of Afro-Eurasia and later the world, right? So here we're talking about world system theorists, all right? The closer you are to this network, like Silk Route specifically, the faster you obtain the military technologies, which typically are invented once somewhere and then rapidly spread. So it is a characteristic of world system rather than any particular society within it. And the world system includes most emphatically the non-state societies, such as the Great Steppe nomadic societies, which both invented a huge share of military technologies, and also, even more importantly, were the route through which these technological innovations have spread through the Afro-Eurasia. So here we're talking about what Diamond sometimes calls about the continental axis and things like that. Hopefully I answered your question.
Yeah. Thank you.
Okay, someone else? Hand signal? Anyone else? Alex Masaudi?
Yeah, hi, Peter. Thank you for your talk. So I was wondering about the one of the functional variables was provision of public goods, and it was not significant. I was wondering if you could tell us a bit more about that, because I guess under multi-level selection, you might expect provision of public goods, assuming it's within groups, you would expect that to be maybe a significant predictor.
Yeah. So provision of public goods, I don't have a slide to show it, but we treated it in a similar ways to governance. So it has like 13 different binary variables, which include things like infrastructure, so provision, building roads, bridges, other types of infrastructure, ports, markets. Then what else is granaries for storing food, systems for storing and distributing water, irrigation, and so on and so forth. All right, so it turns out that when we look at this variable, it is certainly affected by the drivers such as agriculture and interstate competition, but it is not a predictor for other types of variables. There is a strong correlation. So apparently, what happens is that things like governance or information systems, like writing the different types of text and so on, provision of public goods and infrastructure, and sophistication of money, right? These are all highly correlated amongst themselves. And so they tend to arise together as the competition between societies is intensified. Now, one limitation is, keep in mind that because our time step is 1 century, some shorter, faster acting causal factors will not be detected by this analysis. So it is quite possible that, for example, provision of public goods is actually a causal factor, but it acts on a such fast time scale that it will be invisible to our more coarse-grained analysis. All right. So there, the way to approach those is to increase the time resolution of the analysis, which is something that we are attempting to do. And then we would be able, because we do see we know that our analysis at the century resolved time scale doesn't capture everything that's in it, because when there's a statistical approach, we can see whether there is more. Does our best fitted model capture all the correlations? No, they capture a big chunk of cross correlations between different variables, but not all of it. So there is more, interesting stuff going on. Just to emphasize that our approach is not panacea. That's not going to give us everything that's known, that's possible to know. And with better resolved data, we may be able to get at those additional causality errors.
Well, thank you.
But in any case, this would be an additional thing, because the fitted model actually does an excellent job predicting about 90% of variable in the cross validation setting. So we are not capturing everything, but we have captured a lot.
Okay, other questions or comments? Going once? Going twice? Anyone else? JS. Jan William. Do you have any more, Jan?
If nobody else is responding, then
go ahead.
I would like to ask you if you can speculate about what happens in these 4,000 years. So you were talking about this gap in the table, and the gap between what was it, the agriculture, and then the eventual large-scale states, and this gap of 4,000 years. Would that have something to do with what you were discussing previously with Alex about the time resolution and maybe causal factors going on at a faster on faster cycles on a smaller scale? Do you have any idea of what you may or may not be capturing that explains this sort of pattern of 3,000 to 4,000 years?
Yes. So there are two patterns. One of them is that remember that agriculture, if we look at the appearance of common agriculture, all right, then there is this characteristic gap of 2,000 years. And many people have noticed that, like Ian Morris, for example, has also speculated that it's not extremely tight, but it is fairly tight relationship. And of course, it's a necessary condition. It doesn't explain, it's not enough to generate macro states, for example. So what's happening here that cultural evolution, the effect of agriculture takes a long time to unfold, all right, thousands of years. And that's, so this type of long time lags is something that is well captured by our analysis. So let's look at the other one. So yeah, here, and by the way, this is this 300 to 400 years. So intensification of warfare acts faster than intensification of agriculture. Instead of 2,000 years, their characteristic time gap is 300 to 400 years. So here, and this, we see the same thing with other military revolutions. So if, for example, if you look at the gunpowder revolution, then it also takes about 300 years between the appearance of cannons in Europe and the substantial increase in the social scale of the European empires, which are global. So here, we in fact, many people have looked. I mean, we have a pretty good idea, for example, how it all happens. So in East Asia, if you look at 400 BC, this is the Warring States period, all right? And so the new military technology is horse riding. It was adopted, and we actually have some, know quite well in details how it was adopted. It actually required many cultural changes. So, for example, the Chinese elites had to switch from wearing robes to wearing trousers, because you cannot ride a horse in a robe. I mean, you can, but it's not a very comfortable thing to do. And there was quite a lot of discussion to overcome the cultural inertia that would result in the adoption of barbarian clothing styles, right? But the necessity, the military necessity has driven this, right? And then we see it very vividly how during the Warring States, first of all, the multitude, smaller scale states in China coalesce into 7 larger states, and then one of them, Qin dynasty, unifies China. And very similar things happen in other parts of the world. So we know quite in detail what happened in the Mediterranean region. For example, same type of Warring States period, and then larger states such as, of course, Rome, but also Carthage and Macedonia and Pyrrhus and so on appear, and then one ring to rule them all by the 1st century BCE. So here, detailed historical analysis supplements our very macro scale approach that I showed in the table, and we can actually see in detail how this proposed mechanisms result in increases of social scale and complexity. And the final note is that because these cultural evolutionary processes take, substantial time, either 2,000 years, as in case in agriculture, or 3-4 centuries, as in the case of military technologies, our approach at sampling data at 1 century intervals is quite well suited to capture causal processes that unfold on this particular time scales, all right? But shorter time scale processes on the scale of years or maybe even decades will be invisible to this approach. This is my answer to Alex, for example, would be relevant here. Hopefully I have answered your question.
Thank you.
Well, if nobody else has asked a question, I'm going to ask one, if that's all right. In many respects, your approach, you call it cultural macroevolution and so on, but in many respects, it seems to resemble traditional stage theories of history, from 1 to 2 to 3 to 4, like in your iron metallurgy to cavalry to so on. How much do you think your view of macrocultural evolution actually conforms to the inspiration that most modern cultural evolutionary theories do from Darwin's descent with modification? From one common ancestor has descended many different kinds of things. Let's say you had states. How do you go from states to both autocracies and democracies, say, or something like that? A divergence.
Yes, yeah, thank you for this question. So first of all, I was trained as a biologist, and when I switched fields to go into what we call cliodynamics, right, history as science, I was actually surprised, and of course I started reading the literature, especially on evolutionary approaches in anthropology and so on. I was actually surprised by that evolutionary dogmas that have been the subject of so much discussion. So the stage theories. I mean, biologists have a long time, first of all, biologists have a long time rejected approaches that there is some kind of a directionality of evolution. All right, we have looked at mechanisms, and that and they can result in both increase in biological complexity, but also in some cases, evolutionary processes drive decreases in biological complexity. For example, the famous example is, the parasites lose many of their adaptations because they are not needed. So same thing in societies. When the Roman Empire fell apart and there was a multitude of smaller scale societies that occupied, Europe and Mediterranean, what we see devolution, if you will. So many of them lost many of the complexity. They became illiterate. They lost specialized governance individuals and things like that. So there is the directionality. There's no directionality. We see this in our data that there are many advances in sophistication of governance, for example, but there are also many retreats, right? So that's one thing. Second thing, that the stages somehow reify what is a state. We don't ask whether society is a state or not. We break it. This is a multi-dimensional thing. So some people define states as, as the control of the government by the government of coercion instruments. Others focus on internal specialization of governance, and so we try to include those different ideas and others in our in developing a more quantitative scale. And so we don't try to say what is a state or not, but on our we have a sophistication of governance from 0 to 1, and so there is a fairly smooth progression from 0 to 1, as you saw on graphs. Although we do then we can actually rely, when we look at data, what we see. Here it is. We see actually that there are two big concentrations of point, and maybe something between. So some kind of a clumping, all right, does seem to emerge from this data approaches, all right. And what we see that many societies may actually stay. If you look at the trajectories, then they are staying in this region, and then fairly rapid advance, and then they're staying in that region. So something like stages may emerge from data, but first of all, it is not really discrete as was proposed. And secondly, we do see back and forth, all right, and it is rather than imposing this idea on our thinking from a theoretical point of view, this is something that bubbles up as a result of data analysis.
Data.
Okay. Yeah. Hopefully, is that
comes out of the data. Thank you very much, Professor Turchin. That's a really good argument, I think. Okay, if nobody else has anything, I think it's about time for us to say goodbye. And let us thank Professor Turchin once more for being so generous as to spend his morning with us. And the rest of you, thank you for coming, and we'll see you at the next Darwin Club for Social Science.
And thank you for listening.